welcome back for our SEANERGY conference. I hope you enjoyed these 2 hours of offshore renewables conference with the industry association SER. We will now be speaking about the cable challenge that the offshore renewable sector is facing, with projects obviously moving further from the coast, but also newish technologies such as floating offshore wind energy gaining ground. And to talk about that, I'd like to ask Ahmed EL-RASHEED, Francisco OTAL, and Gabriel CANTEINS to join me on stage. Good afternoon.
Works.
Hello. Thank you for joining me here today. Ahmed EL-RASHEED, let's start with you.
Yes.
Can you?
Yeah.
Oh, great. Okay,
Yeah.
you have to hold it really close to your mouth. You are industry director, renewables at UK-based Megger. Thanks for joining us today. Your company provides test equipment for cables at offshore wind farms.
Yes.
And you told me making sure cables actually work and remain functional is quite a challenge.
Yes. Megger is a test instrument manufacturer, as you stated. Our goal is to provide equipment to commission the cables, and then if faults happen, to very quickly find faults. And the challenge that we've been seeing more and more is the nature of the cables, the nature of the environment that the cables is in is quite a challenge. Being able to energize the cables for testing in a safe manner and de-energize them, being able to deal with the longer and longer lengths of cables. From an electrical point of view, the longer the cable, the more...
Did you bring slides? No.
Not for me.
Right.
The longer the cable, the higher the capacitance. To overcome the capacitance to do a test, you need bigger and bigger equipment. So it's quite a challenge to provide portable equipment that you can take out into the field and do a commissioning test or do a fault-finding test as the voltages increase and as the lengths of the cables increase as well.
What kind of solutions have you come up with to solve these problems?
So we have container-based systems, so a container that you can put on a platform or on the back of a ship that then you can use to energize and perform all the different tests that you need to do at a commissioning stage, at a fault-finding stage, and even at just an inspection stage. However, the new thing that we've introduced is to install monitoring, like distributed monitoring on a cable. That helps when you do the initial commissioning, because you can then pick up on partial discharges, you can pick up on issues at the weaker points within the cable, which tend to be the terminations and any connectors that connect one cable to another in order to give you that long length. Having those distributed sensors along the cable and in those weak points, when you do the commissioning test, that then provides you like a distributed profile of where there are weaknesses, where there are issues. And also, when you're trying to fault find, it can quickly pinpoint between the two. So that's been one of the more recent developments that we've had.
And with projects getting bigger, cables getting longer, things are not going to get easier, right? No. So it's common now that the inter-array, so the cables within an offshore wind farm, are around 66 kV, but that's moving up to 130 kV plus, 134. And jumping up in that much voltage, like we have a full-size container system just to be testing the 66 kV systems. So now to go to that kind of level, the amount of equipment you need to perform the testing, to energize it, to de-energize it in a safe way, will require multiple containers. Unless we find a different solution where we can reduce the size of the equipment. Because then that becomes quite a logistical challenge to have multiple containers to
do the resonant test signal that you need to energize the cables. The other thing as well, in the previous session, the one about the French plans for offshore wind, one of the statements that took me back was that they're looking to have wind farms as far out as 1,000 nautical miles from the shore. 1,000-mile run of cable is very difficult to test. We, at the moment, at Megger have the world record for the longest single length of cable to be tested, and that's at 760 kilometers. So going up to 1,000 kilometers is quite a challenge. It means we have to break the world record again in order to be able to test that kind of length of cable. So there's, the voltages go up, the length go up, and the challenges increase.
And what about floating? Floating offshore wind energy is obviously going to be really far away from...
Yes, so floating offshore wind is yet another challenge for cable and testing the cables and fault finding on the cables, because now the cables are dynamic. In a fixed bottom offshore wind turbine, the cable is running down the fixed bottom and then is fixed onto the ocean floor, or is laid on the ocean floor, so it's not moving. But a dynamic cable off of a floating platform, normally you want to use floating offshore wind in a deeper sea, where it's no longer like practical to do a fixed pole. Now that section of cable is moving all the time. It's moving in relation to the platform, it's moving in relation to the cable that's laid on the ground. And that section there, the amount of movement within it, is a high risk for failures, fatigue. And we've seen partners who are cable manufacturers doing a lot of very interesting work to try to make fatigue-resistant cables, materials on the insulation, on the metal itself. However, there's not that much data out there. It's still a new thing, and it is something that we're researching on our end as well, because there's a lot of unknowns with it, and a lot of risk to try to mitigate.
And how do you go about things when you have this scale that is really going up quite fast and you have to do so much longer cables? What's the process to find solutions for that?
One of the bigger challenges is the speed at which technology is advancing. Even though myself and other colleagues in Megger sit on IEC committees and standards committees, it takes a standard committee 2 to 3 years of research before we come up with a standard, a defined standard of what are the minimum acceptable levels for a test, for a procedure to lay things down. And in 2 to 3 years, technology has already moved on. So standards are quite a few years behind what the technology is at the moment. So it's quite a challenge to try to keep up and produce solutions at the rate that the technology is moving at. It's now quite common, like for example, with the case of moving from 66 kV to 134, 132 kV, the move is going, the cables are going to be produced, the turbines are being produced, yet the standards of how to deal with it, how to test it, what are the limits, that is way behind. It's not established yet. We're only at a point where we're now comfortable with 66 kV. But the process is still similar. It still requires a lot of research, still requires a lot of data points, and it requires then research to solve the problems that those data points raise. So still requires some time, but having more people, having more investment, maybe we can speed that up, but we're still a bit behind how fast the technology is moving.
Do you look at other sectors much to get inspiration from how things are done in other industrial sectors? Absolutely.
So the AI revolution, that side of things, that is helping with us trying to process more data, try to produce solutions a little bit faster in order to keep up. But also looking at, for example, what's happening now with the electrical industry, this revolution, energy transition, it's there's similarities with it with the digitization, the internet revolution back in the 1990s. It's happening at a much faster rate, but the challenges, it resonates a little bit with what was going on there. So you draw a little bit of inspiration of how people dealt with it, what happened there in order for us to find a shorter path to a solution. So you constantly look to other industries for inspiration on how to get our head around these challenges faster.
You mentioned AI just now. How about robots? Is that an important part of your business?
Absolutely. So the harsh environment of offshore wind introduces a lot of challenges for personnel to be out there. One of the most common personnel injuries for people who go out to the platform and perform issues is lower limb injury at the point of jumping off of a vessel onto the platform. That is a very common injury, a sprain, a break, something like that. So the use of remote operated vehicles mitigates that risk significantly. Similar with the cable in particular, finding divers who are rated, who have all the specification and they're available and they have the electrical training. So you need a diver with electrical training to dive down and work on the cable. That is also quite a challenge, and that's a bit of a bottleneck. So remote operated sub-sea vehicles do help with that an awful lot. And what we've done is some of our sensors for tracing a cable and pinpointing a fault. We have already implemented those with partners who develop ROVs. So then we don't need a diver to go around. We don't need a diver to go around with the devices themselves. We have the ROV to do that. And then that just reduces the amount of time you need a diver or a technician to jump onto the platform. And when it comes to AI, like I said, there's the installation of monitoring sensors that produces an awful lot of data, and recognizing a pattern that is indicative of an actual fault versus the noise versus just regular things that are happening that are part of the normal operation. That is helped an awful lot by artificial intelligence, by neural networks and things like that. So that's been implemented within our monitoring systems, and it continues to develop at quite a rapid pace.
Well, all this is, I suppose, something that you're in touch with every day, Francisco OTAL. Or maybe not. You're head of renewables at Japanese conglomerate Hitachi. Is the microphone working? No? Sorry, there's another one on the table as well.
I'm here. Yes.
Yes, please hold it really close to your mouth. Really close.
Very close.
Yes, very close. So Hitachi provides all components around cables that make connections work, such as transformers, converters, switch gear. How would you describe the main technological hurdles for your business right now, given the current development, with projects moving further ashore off the coast?
Good afternoon, everybody. Maybe to emphasize what you have. Can you hear me?
Yeah.
Okay, perfect. Okay. Maybe just to emphasize this part, where Hitachi is invited to this session, which is called technological bottleneck of the offshore cabling, okay? Because indeed we are not experts in cabling, okay? We are experts in everything which is in each end of the cable, okay? Whatever is connected through the cable, it is our components, okay? That's some kind of my presentation.
These are your slides.
Okay, then maybe.
Please hold the microphone really close.
Yeah.
Thank you.
But it doesn't work. Doesn't matter. Okay. Then when we talk about technology, as probably many of us remember, some 10, 15 years ago, we were talking about wind turbines on an average size of 3 megawatts, 4 megawatts, 5 megawatts as maximum, okay? And we were thinking, because they were already very big animals, okay? And we were thinking, what would be the next? What is the limit, okay? Now we are talking about turbines that are installed or will be installed in the range of 8 megawatts, 10, 12, 14, new developments already in place in the range of 18, 20 megawatts, and we are still thinking, where is the limit? Okay? So it is a technology in continuous evolution. This is only in terms of size of the turbine. But if we talk about another aspects, it could be the voltage range. It is a similar story. At that time, the standard was 33 kilovolts. Now it is 66 kilovolts when we talk about offshore. But we are already thinking in 132 kilovolts. I don't know why this slide is here.
I don't know either.
Can you move? Next one? Okay, let's keep this one at least. Okay. This is basically an explanation of that I've just mentioned. No? We are in all the ends of these cables. But continue with the technology. There are new things coming. Ahmed has also mentioned about the floating. Floating is not yet a reality, but is there. When we talk about substation, we are talking also about subsea substation. We are talking about integration of different elements inside the offshore wind turbine. We talk about hydrogen, we talk about energy storage to make arbitrage of the energy. So there are many, many differences actually in terms of technology. And maybe two more, this is already an interesting salad, no? But maybe two additional ingredients in this salad. It is sustainability that we need to consider in all the elements, and also digitalization. Digitalization, it is already here, but it is far away to be still a mature technology to be implemented in this kind of offshore wind farms. So that's what we can see in the actual days regarding technology.
With the voltage going up, this is also obviously a problem for you, right? The voltage of the cable.
Well, the voltage will be a very important aspect, of course. As I say, no, the standard it is now 66 kilovolts, and shortly we will be moving to 132 kilovolts. So all this industry will need to move in that area. If you look into that picture, basically it is the inter-array cables that you can see there. Actually, this is 66 kilovolts. Will move very shortly to 132 kilovolts.
And how do you go about dealing with all these challenges? Do you have a strategy? I mean, just step by step, or do you have a big plan?
Yeah. When we talk about, let's call business, no? Business is a very extensive word. Okay, there are different kinds to define the business. If we are looking the way we do business, or we need to do business with our actual customers or even partners, I think it is based mainly in three words, okay? It is, or three pillars, no? It is collaboration, and it is collaboration, okay? We are talking about very big projects with a very long lead times, where to have an early engagement in the project, it is a fundamental piece in order to get the adequate visibility to plan from the very beginning, because we are talking about technologies that probably right now are not yet mature, but we will need them when this offshore plant happen in 4, 5, 6, 7 years. So we need to be very in advance to all our customers in order to be able to define and provide the right solution for these projects. This is considering, let's say, an external approach. When we talk internally, on our side, the main change or the main improvement that we need to do in order to be able to tackle with all these elements that we have just mentioned, it is, of course, to invest in resources, invest in manufacturing capacities, and even more, invest in technologies, because we talk about technology and we need to be in the front end on all these aspects.
And innovation is obviously also at the heart of your business, I suppose. One thing that you're working on, you told me beforehand, are subsea substations, the substations that are not on the water, but under the water.
I think we agree that you will not make that question.
You what?
No, sorry.
You didn't want to do that discussion?
No.
You didn't tell me.
Before going to subsea, okay, maybe as also Ahmed has mentioned, no, as long as we are going far away from shore, the depth of the water is deeper and deeper, and and also there are specific areas, and it can be the Mediterranean area where only 50, 100 meters away from shore, you already have very deep waters. When we go to deep waters, we need to reconsider everything. Deep water could mean 100 meters, 150 meters, depending. Every longitude has their own scenario. But from the perspective of the turbine, I think that only there is one solution. The solution is floating. Okay? We have already erected, or the market has already erected some floating turbines. So this is a technology which is already there. There is some prototypes in the coast of Portugal, in the Mediterranean area. So this is one aspect. But when we talk about the substation part, this is a different animal. And there we have to take several decisions. The available theoretical solutions right now, and don't misunderstand me if I say theoretical, okay? It is, or you go to a floating substation, which basically means you don't fix the substation to the seabed, you put a floater around. This is a huge floater, okay? It is not a minor element. And then you have the floating substation. This is one area. In the floating substation, the state of the art right now, there is some prototypes in a smaller scale, okay, being analyzed. Still early to be erected from my point of view, okay, but there is something, okay. The other option is, instead of putting a floating around the substation, is not to put anything. Then the substation will go directly to the seabed. This is not exactly as I just explained, but this is the concept. And this is something where there is already a lot of information there. There is some research there. And I'm not talking about to put the whole substation as it is in the seabed. We are talking about some main relevant components, and they could be the transformer, they could be the switch gears, and of course all the cabling around. That will be also a challenge. Well, I think it will be less challenge than to have a floating substation from the cable's perspective, because it will not be dynamic. Okay? So probably from that perspective is even better. No? But in any case, it is complicated solutions, a lot of research there, and it will be a moment in the short future where someone will have to decide floating substations or subsea substations. If I make the survey right now to you, I don't know what will be your answer, okay? But both of them sounds at very revolutionary technologies.
Is that something, Rashid, that you're, Rashid, I called you Rashid, sorry, Ahmed, that you're looking at, a harrowing prospect of these substations moving further abroad, further away from the shore and maybe underwater? That makes your business really complicated, right?
Yeah, the prospect of subsea, like on the seafloor substations, it has a lot of advantages, but then does produce an awful lot of complications as well, because now we have a lot more components under the sea. But if it's a floating substation, I think, as you said, the complications might be even more, because we have a dynamic cable, fixed cable that is laying on the ground, then dynamic cable up to the floating substation, then dynamic cable back down again, and then a cable run to the shore. There's just so much more possibilities of failures and fatigue within the cable. So what Hitachi is developing with a seabed fixed substation would help an awful lot.
Would be better?
Yes.
Okay.
Yes. From a cable perspective.
From a cable perspective.
You've got less areas of potential failure.
Right. It might not be that easy to implement, right?
No. There's a lot of challenges there, definitely.
Indeed, I think that it is the only advantage, no? From technology point of view, it will be the cabling. All the rest requires high-tech technology, okay? And I must say that there is already transformers installed in the subsea since more than 10 years. So it is, a development exists already there.
Right. I suppose that the increasing pressure on the seabed, on the sea ground, is quite a problem as well, right, for all the equipment?
Totally hermetic components, able to withstand high pressures, free maintenance, of course, because it will be very complicated to take these operations, okay? But this is part of the research and development that many companies are having right now.
And looking further ahead for your business, do you see any specific bottlenecks in the future?
Well, not exactly in the future. At the end, I think that we all have a common goal. The common goal is to produce the energy offshore and to be able to deliver the energy to the industry, to the houses, etc. So I think that right now there is a lot of different factors that are bottlenecks in order to support the industry. I would say that there are two big blocks. One is all the development phase, till you reach the final investment approval or decision. This is already a big bottleneck. Papers, documentation, permissions, authorizations, to repeat again the same permission, the same authorization. So this is already a big bottleneck. It can take 1, 2, 3, 4, 5 years till you get the final investment decision. So this is only the first part. The second part, after the FEED, is when basically we could enter. And in that area is when the companies, the developers, or the owners must take the decision of purchase the materials. And then because of the industry itself, because of what has happened in the last 4 years, there is a big demand in all the aspects, in components, in engineering service, in many of the areas. So this is also a bottleneck, the supply chains. Actually, in our favor, let's say, we are firmly committed with the industry, with the offshore wind, with the renewables in general, okay? And it was a big surprise also for us, this incredible boom that has happened in the last 4 years. So in that regard, and in order to try to support and to be adapted to the new times, we already announced several billions of investment in the last 2 years in order to increase the capacity of our factories and capacity in many things, okay, resources, products, components, engineering, etc. But it doesn't happen from one day to the other, okay? We can buy or make bigger factories, but we need people to train, and to get right people, I think that right now in the industry, it is another big bottleneck.
And we were talking earlier about the bigger picture, the geopolitical situation, and also the fact that because of COVID, because of the effect of the Russian invasion of Ukraine, at least during a certain moment, the big topic was raw materials, how to get them, that their prices were going up. Is that something that you're still feeling? Has it any impact on your business nowadays?
Well, I think that everything started much earlier than the Russian-Ukraine situation, and even than the pandemic time. I think that it was basically at that time when all these things happened. Many things happened at the same time. As you can imagine, the big companies that we have a lot of research, investigation teams looking ahead, looking the strategy for the future, and no one was aware of this kind of situation could happen, the situation that you have just mentioned. Okay? I think that right now everything is much more stabilized when we talk about raw materials in order to produce the components. I think that another important aspect was the price and the cost. I think that even that part is already more or less stabilized. What we need to stabilize from now on is the long lead times of the majority of the equipments.
The long, sorry?
Long lead times of majority of the equipments. We talk about components that 4 years ago we were able to manufacture and deliver in, let's say, 6 months, and now we are talking about 2 years, for instance. Okay? This is the area where we need to work more together in order to make more accessible these components to the market.
Do you think businesses like yours, sectors like yours, need more public support? Is there something that governments should be doing?
Sorry, say again?
Do businesses like yours need public support, would you say?
Well,
for certain parts of your business?
In some aspects, not especially for us, as component manufacturer, okay? But for the industry, yes, it is needed. And it is an example. The only way to motivate in some way the market is to promote this kind of auctions that are happening so far. Okay, this is a kind of stimulation for the market. And many markets have started in that way, with auctions that along the years will disappear for sure to make the direct business without this kind of support happen. But right now, support of institution is elemental in all the markets, no doubt.
All right, well, thank you very much. Gabriel CANTEINS, you're head of prospective and innovation at French wave energy developer Seaturns. Hello, thank you for joining us.
Hello.
Hello. And your projects will obviously need specific cable connections. To start with, could you maybe tell us about your technology, how it works, where you're at with your projects, etc.?
Bonjour à toutes et à tous. So I'm very happy to speak of wave energy. So Seaturns is developing a wave energy converter. I'll have a short video. Je vais avoir une courte vidéo pour présenter le fonctionnement du système.
I think you bring a slide?
Maybe with the remote. Okay. I think we have the video.
Oh, there we go.
Et on peut la faire tourner plusieurs fois. So I'll explain the operating system of this technology. So this is a floating converter with a cylindrical shape. Its dimensions are 6 meters diameter, 15 meters long, rated power of 200 kilowatts. And inside this floater, there is a water pendulum. The net weight of the floater is 42 tons, and inside there are more than 100 tons of water that are oscillating inside the floater. And this combined movement of the floater and the inner water pendulum will generate an internal circulation of air, air circulating in closed circuit and running an air turbine. So this air turbine, coupled to a generator, will produce electricity. So we have this very simple and robust system that was designed to face the worst sea conditions. It is essential for wave technology to be able to handle strong sea conditions. And as you can see, there are no moving parts outside the floater. So all is inside this white tube, the PTO module, where we can find all those key elements. And one advantage of our solution is that to provide higher power, we can install several floaters on the same mooring line. I mean, Seaturns will not sell single floaters, but typically one line of 10 floaters, I mean 2 megawatt per line. So this is what the solution we are providing. And this technology has been tested in several testing campaigns in a different European university, to test at small scales this concept and to test single and multi-floaters configurations. And more recently, we've tested a prototype at a scale of 1/4. This prototype was tested for more than 1.5 years in France at the entrance of Rade de Brest in collaboration with Ifremer. And so we tested for this long period this prototype in real conditions and also in operating conditions. The prototype was connected to the land thanks to an export cable for electricity. Unfortunately, the prototype was not grid connected because this site is today not connected to the grid. But we could show that we are able to produce electricity and to export electricity to the land. And we faced a major storm, Kiran. It was in 2023. This is an unprecedented storm for the last 35 years in Brittany. And so we are very happy with those sea trials and ready to move on to the next stage.
What's the next stage then?
So next stage, still sea trials, but at full scale. So we are currently, we've completed the design of this demonstrator. I told you the dimensions, 6 meters diameter, 15 meters long. The manufacturing is ongoing and should be completed by July. The objective is to install at sea this demonstrator in the French testing site called SEANERGY, managed by the Fondation Open Sea. The objective is to install this prototype by the end of the summer, should be in next September. And at the same time, we are currently working on the commercialization of the first wave pilot farms. What I call a pilot farm is typically what you can see. No, you can see it. But, a line of 10 floaters.
There you go.
Yes, that's it. So yes, the typical product, a 2 megawatt string of 10 floaters. And the objective in our business plan is to install the first wave pilot farm during the next years. It should be 3 pilot farms worldwide. And the objective is then to move on to the larger commercialization phase in order to supply electricity to grid, but also to industries that need lots of electricity, such as desalination, hydrogen production, data centers, of course, etc.
But obviously, this panel is on cables. So how do you connect these devices? Is it really tricky?
Yeah, tricky. So there are some challenges. First, as I explained, our floater has a quite specific combination of movement. There is a heave movement, a surge movement, and a pitching rotation of the floater. And we need to have a connecting solution that handles with this combined movement. It is quite different from floating wind turbines, because in our case, we force the pitching movement. We need to have this rotation movement of the floater in order to produce electricity. So our connecting solution must be able to adapt to this very specific movement of the floater. And of course, it was mentioned, fatigue. So we tested for more than 1 year a first cable, and it was a great success, and we'll move on to the full scale to see if it's okay. So this solution will be used to connect floaters to a substation, because, as I mentioned, we'll install several floaters at sea. And each floater will be connected to a substation or a hub in order to have a unique cable to then export electricity to the land. Another challenge is, of course, will be the architecture of this electrical architecture. And this will be developed in the next month in order to have the best solution, a good compromise between a quite compact solution, because Seaturns solution is very compact. I mean, on the same surface, we have a very high power, but we need also to handle with the visual impact. And other challenges, of course, we'll install our floaters in some regions in the world where there are also ecological issues. We need to have a solution that will not damage the seabed, for example.
Can I ask the two of you what you think about such a device? Is this giving you nightmares? Francisco.
Well, yes.
Yes,
Okay.
yes, nightmares?
I've been discussing today, with several companies, and I, in general, quite surprised, because I had in my mind some new developments that are the one I've mentioned during my exposition, okay? But then I've been talking with people who was really making very, very fantastic things with new technologies. And I think that this is one of the cases, I would not imagine, that this kind of elements could work. And I'm also thinking, who is the brain who is thinking in these kind of things to continue the technological evolution that we are living. So for me, it is something that we need to consider. I'm still wondering where are the cables there and how is the role that they will play. But for me, it's fantastic, these kind of initiatives.
It must be a technical challenge, though.
Technical, totally, yeah.
Yeah. Ahmed.
From my point of view, I concur. Amazing technology, very innovative. From the cable point of view, in terms of commissioning it and maintenance, fault finding on it, I wouldn't say nightmares, but that's a challenge, what I see. I'm glad the fatigue analysis that you guys have done has proven quite successful. Just as an aside, but linked to it, in the research posters, I think poster number 2 has a topic of cable and cable fault, and it's got like a statistical analysis, and it shows how cable is in itself a bottleneck for this industry, because research papers are being done on it. CGRE and IEC are spending time in committees looking at it, and one of the things it says there, and seen in other research as well, is the longer the cable and the higher the voltage, so the electrical pressure is higher, the risk of failure and fault gets higher. Now, it's not like double or triple, but it does statistically significantly get higher. When you add the dynamic element to it, so what you were describing there with the floater going up and down, back and forth, possibly there's some slight twisting movement as well, maybe. All of that is from the cable side of things. This is a metal conductor with insulation around it. It's a risk that needs to be mitigated. It's not a showstopper, definitely. It's a challenge that needs to be overcome, and I'm sure it will. But for the time being, that is a challenge.
I imagine, yeah. Gabriel, you told me before, and I was asking Francisco about political support. That is something that you've been asking for, right? For cable solutions, that the government gives you clarity about who pays for cable connections in the future, right?
In fact, there is another challenge, that of the cost. The connection to the land is costly. And so maybe one demand would be about how to finance the connection of those systems to the shore, to the land, and to the grid. So in the case of offshore wind turbines, the cost of connection is paid by RTE. So yes, maybe one demand would be to have the same solution for our prototypes. I mean, currently we are also waiting for what in France, le contrat d'expérimentation. This could help us to install maybe the first wave pilot farm offshore in France, and so it could be interesting to have this solution, yes, to finance the connection. Just to give you an example, the order of magnitude of the cost is several tens of thousands of euros per kilometer, and this could lead to a connection budget similar to that of the machines. So yes, we have to work on the budget and to optimize it, and maybe to have financing solutions.
I think we had a slide on that, didn't we?
Yes, yes. So from the
There's one graph. Maybe you could show that.
So
no.
And just maybe a few words waiting for the picture to mention you that Seaturns has a booth in the region Nouvelle-Aquitaine space, so please don't hesitate to visit us. And no, we still don't have the picture. And maybe another word to mention that Seaturns is finalist of the Seaturns Awards. It will be tomorrow.
The Seanergy Awards.
Seanergy.
Yeah. We haven't named them.
Don't anticipate. So yes, Seanergy Awards tomorrow at midday.
Ah, there we go. There
maybe
got the
we
slide.
have it. So this picture is extracted from a document document from NRL, National Renewable Energy Laboratory from the USA, and it shows us the order of magnitude of the cost per meter, in dollar per meter, depending on the power and also the voltage. In our case, we are facing quite low voltages, but yes, this provides us yes, an order of magnitude of what will be the budget. And for if we consider a project with a distance between the waveform and the shore of 7 or 8 kilometers, yes, the budget will be quite consequent.
Now this graph goes until 36 kilowatts. We were earlier talking about 132, so it should be doing that, right, the curve. Thank you very much, gentlemen, for taking part in this panel. Thank you, Ahmed El-RASHEED. Thank you.
Thank you very much.
Thank you, Francisco OTAL, and thank you, Gabriel CANTEINS.
Avec plaisir.
Thank you, and thank you for listening.